I hope you came up with your answer to the problem of writing an expression that would produce this graph of ABC. I want to talk about this now for a minute because there's actually at least two ways to do it. The first way to do it would be to adopt pretty much the same style we used in the H2 case, which would be to just say shared, we'll call it 0, make room A has a single exit to make room B, which has a single exit to make room C, which has a single exit back to A, which we gave the label -0 dash. So we could do all of that and then say -0 dash. And this might be a little bit easier to understand if we use the indentation a little bit better, perhaps more like this. So now we see that A has a single exit to room B, B has a single exit to room C, and C has a single exit back to room A. So that would be one way to write it. Now let me show you another way to write it. And this is the way I actually prefer to use once they get kind of big like this. This new way of writing it you could have used all the way back at the beginning, but it's particularly useful as the graph structures start to get larger. Let me just run that to make sure it works. It seems to. And now let's say H3, we're going to comment out this version of it. And what I'm going to do here differently is two things. One thing is I'm going to use a different convention for the labels. And the other thing is I'm going to give labels to all of the rooms. So for the different convention, rather than calling them -0 dash, I'm going to call them by their letter names. That works just fine. There's no reason I have to use numbers in there. So I'll just call this -A dash, make room A. I'll just leave this blank for now. And then I'll do that 3 times, except I better be careful to do that, and that, and that, and that. And now I can fill these in as, well, A has a single exit to B, and B has a single exit to C, and C has a single exit to A. And we'll produce as the root room, or the first room in this graph, A. And that will work too if we understand that by drawing the arrows the way we saw before. Let's see, this arrow from A's exits goes to the room B, and this arrow from B's exits goes to the room C, and this arrow from C's exits goes to the room A. So it produces a kind of messy version of the graph we had before. A funny thing here about graphs is that drawing them nicely is actually not easy to do. By default, a graph ends up looking kind of messy, and you have to make it look nicer in terms of arranging the arrows nicely. So that works, but let's look at something important here. If we ask to look at H3, it shows us this upper version of how to textually represent the value. So Racket doesn't remember that we used A, B, and C. It doesn't remember what we did. It shows us the version that it wants to show us. In some sense, what it's trying to do is use as few labels as it can rather than use as many labels as it can. So you just have to be ready to look at that. And as I said before, one way to look at it is rather than read that directly, you might say, well, what's the name of this room? Oh, it's A. And how many exits does it have? Oh, it has 1. And pick apart the value that way if you find it difficult to read the value this way. Another way you can help understand this is to look at the value and kind of in your mind draw that little arrow. And that might make it easier to understand this way of looking at cyclical structure. But one important thing here is, cyclical structure has this funny property that it doesn't show up in text very well. That's not a property of the teaching languages. In fact, Racket is showing you this cyclical structure in a much easier to understand way than most other languages would do. It's cyclical structure that's complicated, not the way Racket is showing it to you. So what I'm going to do now is I'm going to get rid of this version of it, keeping this version that I find easier to read, and we'll just do this last example, which is the hardest one. So define H4, house 4 is, I'll do a shared, and I'm going to use this convention that I did the last time, where I'll name the labels according to the room names. And let's see, there's 6 of them. So let's first get myself room for 6 rooms. Haha. And we know we're going to produce that first room. And the rooms are named A, B, C, D, E, F. A, B, C, D, E, F. And now I can read off the complicated part directly from the picture. Let's see, A has exits to B and D. B has exits to C and E. C has a single exit back to B. D has a single exit to E, and E has an exit to F and one to A. And let's see, F has no exits at all, so we'll replace that list with empty. Or if you want it to look similar, you could just do that. List with nothing in it is empty list. Let's run that and just make sure it's well formed, and it seems to be. And we can see how Racket wants to show that to us. And here, it's not really quite doing it the way we said. Okay? It made 3 labels, and it's given them some strange numbers. But if we tease that apart, if we draw the lines for each of the labels, we'll end up getting that graph, even if it doesn't immediately look like that graph, even if we have to sort of pretty it up a bit. So that's how we construct cyclic data. We've never been able to do this before. We can only do it in the advanced student language. But using shared, we can use these little temporary labels to textually represent cyclic structure. We use that to write expressions that produce cyclic structure, and Racket uses that to show us back the values containing cyclical structure as expressions.